So we want to evaluate the integral of e to the x over e to the 2x plus 3 e to the x minus 4. I want to give this a try. Go ahead and pause the video. I'll be right back. So let's look at this integral now. First, we note that we can factor the denominator here into e to the x minus 1 and e to the x plus 4. We know the derivative of e to the x is e to the x. So let's let u equal e to the x. So du would be e to the x dx. Derivative of e to the x is e to the x. So we have that. So now let's go ahead and transform this into an integral involving the variable u. So we have e to the x, and d to the x here is a product. So that's right here. That can be replaced by du. And then on these factors, we have e to the x, replace the e to the x by u. So we have u minus 1. And e to the x plus 4, replace that e to the x by u. Get u plus 4. And this is just a partial fraction problem here. So we could have 1 over u minus 1 times u plus 4. So the integrand can be broken down by partial fractions. They're linear and not non-repeating. So it'd be some constant a over u minus 1 plus some constant b over u plus 4. And you clear the fractions by multiplying by the LCD u minus 1, u plus 4. So this would give me a 1 equal, and then here a would be multiplied by u plus 4. The u minus 1 would cancel, leave me with u plus 4. Multiplying the second fraction on the right here, the u plus 1 would cancel. The u plus 4, I should say, would cancel. And leave me with b times u minus 1. And they're very similar to some of the other ones we've done. We can pick values for u and eliminate one of the constants. For example, here, if I replace the u by 1, the b cancels, and I get a is equal to 5. I'm sorry, I get a times 5 is equal to 1, so a is 1/5. And then if I let u equal to -4, the a would cancel, and over here I had -4 minus 1, so b times -5 is equal to 1. So solving for b, I get b is equal to -1/5. So then this integrand right here, we can write it then in terms of what these results. So it's going to be the integral of a, but a is 1/5, over u minus 1 plus, and then it's b, but b is -1/5. That's over u plus 4, and that's to u. So again, you can break this down into two integrals, but we'll do it from here. For the first one, I have coefficient is going to be 1/5. I could bring that out, and this would be 1 over u minus 1. So that's like a 1 over u. Anytime you have a linear factor like that, the coefficient of the variable u is 1. It's going to be natural log of that expression. So integral of the first part right here would be 1/5 natural log of absolute u minus 1. And then I got the minus 1/5 for the next one. Again, same thing. That's going to be integral of 1 over u plus 4. So that's natural log of absolute u plus 4. Plus the constant of integration. And we'll move over here to this side. So I'm going to factor out the 1/5 here. I have the 1/5 out here. And then you look at the natural log of u minus 1 minus the natural log of u plus 4. And remember, u is e. So using the properties of logs, I can write that difference as the log of a fraction. So this can actually be written this way. I'll put the equals here. This would be the natural log. And I'll put one absolute value here. And it's u minus 1. But remember, u is e to the x. So it's e to the x minus 1. And that's going to be over u plus 4. Okay? But u is e to the x. And the constant of integration. Now you could leave it this way. Just to put e to, where you have the u, put e to the x over here. This is just simplifying it. Depends on what your instructor wants. So here I just factored out the 1/5. And anytime you have a difference of logs, you can write it as a log of one expression, mainly the first one over the second one. So there we have it. 1/5 natural log of absolute e to the x minus 1 over e to the x plus 4. So this is the final answer in simplified form. Thanks for watching. We'll see you next time.